Hi, this is Mr. Manley, and I want to take another look at the 3x3 system, linear system, that has infinite solutions. Here's a 3 system, 3 variable, with 3 variable equations. I'm going to number them 1, 2, and 3. I'm going to grab 2 of them, 1 and 2. I will multiply the first one by 2. Let's check and make sure that I did that correctly. That'd be 2x minus 4y plus 2z equals 6. So yes, I did multiply by 2 correctly. I'm going to bring down the second equation. And subtract. Subtracting 2x minus 2x is 0. Negative 4y minus negative 5y is y. 2z minus 6z is 4z. And 6 minus 7 is negative 1. Okay, here's something fun that happened. I just realized that I copied down the wrong system. Rather than starting over and finding the system that I was going to use, I know that I want this to come out to infinite solutions. So I've already used equation 1 and 2. The question is, how would I change equation 3 so that it will, because right now the equation 3 that I have is going to have one solution. So how would I change that so that it has infinite solutions? So I just went down and jotted down, worked this out on scratch paper. It took me a couple of minutes to work out what should equation 3 be. And I found what it should be so that we will have infinite solutions. So we're going to change equation 3, and I'm going to change it to this. (3x minus 5y minus z equals 8). And now I think we'll have infinite solutions. So that's an interesting exercise for you. If you just could you find a 3 variable, 3 equation system that has infinite solutions? Just make one up. And that's a really nice little exercise for you to try if you're interested. Okay, so what do I need here? I need equation 3, and I can combine that with any other equation. I'm going to choose equation 1. So remember, since I've used equation 1 and 2, I have to use equation 3, and then I can combine equation 3 with either one of my choice. Okay, so bringing down equation 3. It goes 8. And then equation 1, I'm going to have to multiply by 3. It's 3, 6y, 3z, and 9. And then I'm going to subtract those 2 equations. And that's negative 5 minus negative 6 gives me y. Negative 3 minus 3 gives me minus 4z. And 8 minus 9 gives me negative 1. So yes, in fact, this is matching this, so I am going to have infinite solutions. When I combine those two, I combine this one and this one, I'm going to get 0 equals 0, infinite solutions. But as we know, in pre-calculus, we're not going to leave it at that. We are going to let one of the variables equal some other arbitrary fourth variable. and I am going to let y equal a, and then letting y equal a, I will find z in the equation that I have here. I'm plugging in this a for y in that equation and then solving for z. And that will give me a minus 4z equal to -1. Solving for z, I get negative a minus 1 divided by -4, and that's z. Now remember, the objective for these systems is always to find the coordinates of the point where they intersect. Of course, in this case, we have infinite points where they intersect, and we are going to still represent that with the 3 coordinates, but it's in terms of this 4th variable for which there are infinite possibilities. So let's see, y is a, and we just said that z is, I think it'll look a little nicer if I call it a over 4 plus 1/4. And then we need to find x. I'm going to go here, find x, and I will plug that into the first equation. X minus 2a, because y is a, plus a over 4 plus 1/4, because that's what z is, equals 3. And then I'm going to multiply through by 4 just to get rid of the denominator. So 4x minus 8a plus a plus 1 is equal to 12. Let's put a barrier there. 4x equals negative a plus a is negative 7a, so I need to add 7 to the right side, and then I've got this 1 that I'm subtracting, so that'll be 12 minus 1 is 11, and x is equal to 7 over 4a plus 11 over 4. And we'll take that up to represent the point where the lines intersect, which is actually an infinite set of points. 7 over 4a plus 1/4. Okay, so I want you to copy all of that down, work through that, and then you're going to do a problem on your own. Remember, we can choose whichever variable we want to be a. Now in this case, our choices, look over here to the left, are limited to y and z. Wouldn't make sense to choose and let x be equal to a. So I'm either going to let y equal a, or I'm going to let z equal a. And that's the solution to an infinite system, to a system that has infinite solutions.